How did you guys write this without the trig function? So hopefully you wrote tangent x squared plus tangent x minus 2 equals 0. And if you don't write the trig function, you just have x squared plus x minus 2 equals 0. Raise your hand if you saw that. Okay. So in this situation, there's a couple of ways of solving quadratics. Let's brainstorm how to solve quadratics. Talk about this first semester. How would you solve this problem up here? Factor. What else? So that's factoring. Completing the square. Graphing. X equals negative b plus or minus. And the last one we did in the last problem is actually called the square root method. So here are multiple ways of solving quadratics. In our class, I'll just be focusing on factoring. Everyone say, thank you, Mr. Ng.
Thank you, Mr. Ng.
We'll focus on problems that actually are factorable. Okay, not prime. So that means if you cannot factor this, I would suggest going back to reviewing how to do that. As you'll notice in the next couple of weeks, as we go on more in math, you'll notice that I'll be doing a lot more side work on the side to help you understand what's happening. If I wanted to factor that, because your a value is equal to 1, a times c is what? 1 times negative 2 is negative 2. Your b value is what?
1.
Two numbers that multiply to be negative 2, but also add
2 and negative 1.
these multiply to be negative 2. Does that add to be positive 1?
Yeah.
So my answer here is 2 and a negative 1. And remember, you don't need to do the box because you have an a equals 1. Now normally we would write just x here, right?
Yeah.
This 2 is positive, and you would just write an x. Well, look above. What trig function do we have? We have tangent. Remember, if you did FOIL or you did the box to multiply, that's tangent squared x, negative 1 tangent x, positive tangent 2x, negative 2, combine like terms, and you'll get the equation above. Alright, so I have two factors now and they're set equal to 0. I can apply the zero product rule. Let's make two equations set equal to 0. What do I write here? I'm just going to go ahead and solve each of these. Subtract 2. I'm trying to solve for x, which means I'm going to have to take the inverse. So here I have tangent of the inverse of negative 2 equals x. I'm going to do the same thing on the other side. Take the inverse. Inverse is shown by the arrows and having of this negative 1. So tangent of inverse of tangent of 1 equals x. Let's locate on our unit circle where tangent is negative 2. That's also y over x. You guys see any locations there? Someone said 3 pi over 4. Okay, this would give us radical 2 over negative radical 2, which would give us negative 1. So this would answer, well, this one I'm looking for positive tangent. So that would be our pi over 4. Notice how I'm using radians. So over here, this would be pi over 4. Any other locations where tangent's positive? Third quadrant. Negative over negative is a positive, so 5 pi over 4. Now over here, the great thing is we have a calculator-ready equation, so you can actually take out your calculator. I notice in this problem that we have radians. And now I'm going to do, so radians. I'm going to click second to get my inverse of tangent. So let's do negative 2. Remember, the negative sign is different than my plus or minus if you're using your calculator, which I don't have right with me right now. So I'm going to click on the inverse of tangent of negative 2, and I get this answer. I get negative 1.107 radians. But let's think about that. Is negative 1 radians in between here? Do you see that? So that's outside. So what we have to do is add a coterminal angle. So we would have to add a full rotation, which is 2 pi. And 2 pi is approximately what? 6.28. So I can just add that. And you get approximately 5.176 radians. Okay, so here are the solutions that we have. I have 2 solutions here and 1 solution here. Remember, we did this back in the beginning of the semester, and it's in radians, and this radians, negative 1.1, is not within my interval. My interval is between 0 and 2 pi. Pi is approximately 3.14, so it has to be between 0 and 6.28. I added a coterminal angle there, and that gives me approximately 5.176 radians. So there's my 3 solutions.